The GNSS project mode of Starpoint GNSS Analyzer is used for analyzing GNSS data and results created using Starpoint. This mode first determines if you have trajectories or baselines in your GNSS project. If you have trajectories, then the views you can use are Google View, Quick View, Residuals, Position Standard Deviation, Speed, Speed Standard Deviation, Height Profile, and DOP. If you have baselines, then Google View, Quick View, and Residuals will be available as views. First, let's look at trajectories. Using the Google View, you can display your trajectories with a map background, as long as you are connected to the Internet. Specific symbols are used to present the positions accurately. Each GNSS position that is part of your trajectory is symbolized as a point on the screen, and clickable to directly obtain GNSS information for that point. On the Parameters panel, you are given the project's file path and file name. You also have a checkbox to show sites. Clicking on this checkbox will display any extra parameter sites that may be in your project. In the Representation Type area, you can choose if you want your positions to be labeled by solution type or by accuracy. If you choose solution type, then your positions will be color-coded with green for fixed, orange for float, and red for pseudorange. If you select by accuracy, then your positions will be color-coded to one of 6 colors, ranging from light green for positions that have 1 to 0.05 meter accuracy, up to red for positions that have accuracy greater than 5 meters. The Quick View is useful when you don't have an internet connection. It contains similar information to the Google View, but without the map background. Hovering your cursor over a position will bring up additional information about that position. The Parameters panel for Quick View is identical to that for Google View. The Residuals view displays observation residuals for code, Doppler, and carrier phase data. This is useful for detecting problems in the dataset. Please note that smaller carrier phase residuals from a fixed point are indicators of accurate positions. The Parameters panel has several more options than the previous views. First, you were given the addition of the current trajectory and time information. Under the Components area, you can choose an observation type of either code, carrier, or Doppler. You can also select to have the chart indicate where there's been a cycle slip, and you can set a residual range between 0.1 and 50, or have it set to auto. Under Constellations, you can choose if you want to display either GPS or GLONASS satellites, and you can manually exclude specific satellites if you do not want them included in your analysis. Next is the Position Standard Deviation view. In the Parameters panel, you can choose if you want to have latitude, longitude, height, and planimetry displayed on the chart. The Speed view is typically used for hydrographic and aerial surveys. The Parameters panel gives you the same options as the previous view, allowing you to display latitude, longitude, height, and planimetry components. Next is the Speed Standard Deviation mode. This mode is very similar to the Position Standard Deviation mode, only instead of showing changes in distance over time, it shows changes in speed over time. The Parameters panel options are identical. Next is the Height Profile. This is a useful tool for analyzing the smoothness of a vertical profile to detect anomalies. The Parameters panel options are very basic, but you do have the option of turning on and off sites. The last view for trajectories is the DOP view. This view shows you the dilation of position values for a specific data file of the GNSS project. In the Parameters panel, you can choose if you want to display PDOP, which represents 3D parameters, GDOP, which represents all parameters, HDOP, which represents 2D parameters, VDOP, which only represents height, TDOP, which represents time, NDOP, which represents north parameters, or EDOP, which represents east parameters. If you have opened a project that contains baselines, the available views you will see are Google View, Quick View, and Residuals. In the Google View, you can see your network baselines displayed with a Google Earth background. The status of the baselines is color-coded, with orange representing a float solution and green representing a fixed solution. If you click on a baseline, a text window opens telling you the name of that baseline, and the baseline turns pink to indicate that it has been selected. If you click on a site, then a dialog box appears telling you the information for that site. In the Parameters panel, After you have selected a baseline, you will see the project path and name, the current baseline's name, status as it was computed by Starpoint, the datum, a 3D solution, and a geodetic distance. The time section gives you the process interval that was selected in Starpoint, the start and end times, the duration, the total number of epochs, and the number of epochs solved. The base and remote coordinate sections display their coordinates in the datum, and you are even given a standard deviation for latitude, longitude, and height. The quick view gives you the same information as the Google view, but without the Google Earth background. To choose a baseline in quick view, you must select it from the drop-down list at the top, since the chart is not clickable. Hovering the cursor over a site will bring up a dialog box with information about that site. The parameters panel gives you the same information you were given in the Google view as well. The final view is the residual view, which displays code, Doppler, and carrier phase data. This view is useful to detect possible problems in the dataset. Smaller carrier phase residuals from a fixed solution indicate more accurate positions. In the parameters panel, you are given the same information from the previous views, with the addition of the component section, where you can choose your observation type, select a residual range, and choose to show cycle slips. Also, you now have a constellation section, where you can choose between GNSS or GLONASS, and manually exclude individual satellites from your analysis.